Welcome to this tutorial on how to use Climpact. Climpact is a software package to calculate climate indices that are relevant for health, agriculture, water, and other societal and economic sectors. Climate indices calculated by Climpact are adequate also to document climate variability and change in the climate science basis of a project proposal intended to be submitted to the Green Climate Fund. In this tutorial, we are going to learn how to use the newly released Climpact3 web-based version. So the first thing we do is that we open a web browser and go to the website of Climpact, which is located at www.climpact-sci.org. There, we find the website where Climpact is documented and where it can also be used directly in the web browser. We choose this link here, Start Using Climpact. And then what we see is this website to get started using Climpact. Once here, we are going to launch the web version of Climpact. We click that. And there it is. Here we have three options on the left side of the screen to run the software completely online. We can process a single station, which is the example that we are going to do now. But we could also use the software to batch process several stations. And also we have a link to the documentation. Luckily, Climpact has been extensively documented, and I strongly recommend to read the user's guide. Here you see that the user's guide contains everything about the software, background on the indices, how to install it, how to use it, a table in Appendix A about all the Climpact indices, and many other things. Well, let's get started. We're going to choose the option on the left top side of the screen to process a single station. In order to process a single station, we click then in this option, and we are taken to this web page. Note that on the top of the website, we have the options number here that will take us through the steps to produce the Climpact indices from a single station. On the right, we'll see additional help on how to use each one of the website sections. And also we have links to sections of the user's guide that are useful in the context of what we are doing. This is step one. We are going to load station data and provide metadata. For this example, I'm going to use the Sydney Observatory Hill time series. And then I'm going to right-click on the name of the file and save it, let's say, in the downloads folder. So I can load it for Climpact. The user guide explicitly says that in order to upload files for Climpact, they must be in plain text format, and the file must consist of 6 columns. Such 6 columns must be the year, the month, the day, followed by the daily values of precipitation, maximum temperature, and minimum temperature. We can see an example here. This is the text file that we are going to use in this example. Year, month, day, precipitation, maximum, and minimum temperature. Good. So we select Browse in order to select the file, which is this Sydney Observatory Hill. And we open it. The website uploads the data. And immediately after that, what we do is to enter the metadata. The metadata consists of the geographical location of the single station we are processing. So for this example, we specify it, and it has to be written in decimal degrees. Then we specify the latitude, and then the longitude. And after that, we need to specify as well the base period. The base period is the subset of years that are going to be used as a reference to calculate all the indices. In this case, our data are long enough to use the base period 1971 to 2000. Once we have infilled all these values, we can continue then to the next step. So we click Next, and then we are in step 2, check data quality. Data quality are of the highest relevance in order to calculate the indices. And for this, the recommendation is to have the National Meteorological or Hydrological Service involved in making checks of the data quality of your time series. However, this step is designed just to make sure that we do not have in the time series mistakes or erroneous values that could lead to equivocal conclusions on what is going on with the data. We simply click on Check Data Quality, and then a series of tests are applied to the time series in order to find if we have suspicious data, outliers, or if we have data that need corrections. A more in-detail explanation of the quality control process performed by Climpact is provided in a separate tutorial by Nick Harold, and I recommend to also have a look to that video tutorial to learn more about the quality control process. The quality control process produces several plots. Here, for example, we can select each of the plots that were produced with the quality control. For precipitation, for instance, Climpact produces a histogram so that we can see how our data are distributed. And also, the software produces time series plots for the daily values so that we can see if we have, for example, here in 1942, in the early months of the year, we have this very, very high precipitation value. And that needs to be checked to see if this is an actual extreme that is known, or if it was a potential error when digitizing the data, etc. Here is an example for temperature. What we basically look in the daily time series of temperature is that it has the annual cycle there, temperatures that are cold in winter, high in summer. And we will see there also some values that are extreme. And all of those need to be checked. We need to make sure that all of those are real extremes. These red circles at the bottom of the plot indicate dates where we have missing values. A series of box plots are produced as well as part of the quality control, just to check if we have outliers and how many values are exceeding the limits and consider extreme values. Anyway, as I said, I recommend watching the tutorial on the quality control to learn more about the process. The thing to do once the quality check is performed is to proceed to make corrections in the time series and then redo the steps again. On the right side of the screen, we see that we can also go to Appendix C of the user guide, where more detail is provided about quality checks, and we could also download all the plots that were produced for the quality control. For the purpose of this tutorial, we are going to assume that our data are now with the best quality possible, and having said that, we are going to proceed to the next step. Step 3. Step 3 is the indices calculation. In the indices calculation section, we can put a customized plot title. Here, I will leave it by default as Sydney and the coordinates of the location. And in this section, we can specify as well those parameters for indices that are user-defined. Some of the Climpact indices, such as the warm spell duration index, we can specify how many days we want to take into account, for example, for a warm episode to be analyzed, for a cold episode, or also for the number of days that rainfall happens consecutively, etc. Here, I'm going to leave this with all the default values, but this is something to pay attention to if you are interested in these indices. If you position your mouse above the box, then a text box is displayed, providing additional information on what the index is and what these values should be in case anyone wants to customize them. And also, again, on the right side of the screen, there are links to the relevant sections of the user guide and some short explanations on each of the indices definitions. Right. Let's consider that we are ready here. Just continue with the example, and then we click on Calculate Indices. Climpact proceeds to the indices calculation. It takes a short amount of time because it is calculating now the more than 60 sector-specific climate indices, producing plots and also producing the indices files. Okay, so calculation has been completed now, and the plots are displayed here. Each plot is an index that was calculated by Climpact and was plotted. What we have here is then the title that we selected, followed by a description of the index that is displayed on the screen. This index, for example, here is the standardized precipitation and evapotranspiration index for 12 months. It is a measure of drought using the standardized precipitation evapotranspiration index. And then with the plot displayed here, we can begin our climate analysis and see which years we had dry periods, the ones in red, on which years we have wet periods, the ones in blue, and also we can see if a trend exists in the time series as determined by the Mann-Kendall test. We see the slope value there. So what we will see here is the more than 60 indices as plots. And if we click on any of them, we will see the index plot, and we'll be in the position to analyze what happened year to year with a specific index, and also to analyze if we have some trends. When building a case for a proposal to the Green Climate Fund, this is important because then we can identify for a specific variation of the climate what has been going on, and then provide useful information based on the data about the climate behavior in the specific location that we analyze. Again, on the right-hand side, you can read short pieces of text for additional guidance, and also download the indices plots and the indices data. Finally, a new feature that was introduced in Climpact3 is this new module, step 4, that allows the user to calculate and plot sector correlations. So we certainly have produced now indices from the climate data, but it is interesting to explore if a relationship is found when relating the climate data with some sectoral data. For this example, the Climpact website provides the wheat yield data in New South Wales from 1992 to 1999. This is a file that is also in ASCII text. It is a comma-separated value file. And I'm going to save it to the download folder in order to tell the software that I'm going to use this sectoral data to look for correlations with the climate data. Okay, there it is in the downloads folder. Then I select the browse button and select the sectoral data here. Okay. This file is made of yearly yield wheat data. And you might know that the time period of the sectoral data is not exactly the same than the climate data, but Climpact3 will use just the years where both sources of data have information in order to produce the correlations. It is highly recommended to check the box for data to be trended, and we can proceed to the correlation calculations by clicking on Calculate Correlations. And similarly to the previous modules, plots with scatter plots of some climate indices, for example, this index, there is about 30 degrees against the wheat are produced. We can also see that a linear regression was fitted to the data, and the R-square value is displayed along with the equation for the regression. In this way, we can determine if our climate indices are somehow correlated with the sectoral data, providing additional information to support the claims of climate influencing some specific sector. It is possible as well to download the files that were produced here, and we are done. This is it for the processing of a single station. I hope you liked the tutorial. Please feel free to send questions and comments to the email addresses provided at the website. And also please visit the other tutorials that are provided for the use of Climpact. Thanks for watching.